Hello, everyone, and welcome to another episode of the Day Zero podcast. I'm Spectre, with me is Z. Sorry we couldn't go live this week. We will be back again live next week, though. Just some last minute stuff that came up yesterday. But yeah, that was just one of those events that only happens every so often. With that said, today we've got some vulnerabilities which vendors struggle to fix, as well as the latest speculative execution attack that surfaced on Zen 3 CPUs. Kind of interesting. We got a bit of a reversal of fortune with Intel and AMD. But yeah, we'll get into that in a little bit. We'll start off, though, with a fun post from Portswigger. So this is a parody of OWASP's top 10. As you can guess, it came out on April Fool's Day. The top 10 worst reported vulnerabilities is what this post is about. Now, as always, with these kind of top 10 lists, I don't think we're going to cover every entry on them. I'm just going to cover a few of them that I found like notable or funny. So number 9, I think was pretty good. Useless information disclosure. So basically what they did here was they went through like various things they've seen in bounty reports and whatnot, and just kind of summed them up and looked at which ones were just bad reports, just kind of bogging down the bounty or the research program. And one of the ones they found.
I'm not going to lie, I felt a little bit attacked reading this because I have definitely reported on some things, but I think that also illustrates the difference between being hired for like an assessment, you're brought on to do that thorough sort of assessment versus a bug bounty trying to get the money out of it. A lot of these things will even be called out as not in scope on like a ton of bounties, and you will still do them anyhow. But with an assessment, I kind of take more of the perspective, I'm going to give the client the information they need to decide whether or not it's useless to them or not. Of course, as they mentioned through this, some of them are things that, like, as the researcher sitting there, I can sit there and be like, yeah, I know this doesn't matter. Like, a page missing. One of the other examples is missing some of the security headers, like prevent clickjacking. It's like, but they have nothing to click on, no form to actually perform a clickjacking attack with. You don't report about the missing header because of that. So case like that, yeah, like I wouldn't report on that, but some of these I've definitely have reported on. It's just like, I know it's a low severity issue. Here's the information, how you can deal with it if you want to, or you can make the decision on your own. So I do think it kind of illustrates the difference there a little bit, but felt a little bit called out there regardless.
So mostly what they're talking about here are the types of issues that you can get very quickly just running a vuln scanner on something and then just taking, like, copy and pasting from the vuln scanner into a report. That's what I think a lot of like what they're trying to tackle here is. So yeah, number 9 was the useless information disclosure, and what they classify there is things like disclosing the backend server technology like Apache or Nginx or whatever. And they make a funny quip in there about how that opens the floodgates and means your server will totally be hacked. So you need to deploy a reverse proxy, which will never backfire on you. There's some fun quips like that in the article.
The header thing, like the reason for that ever being called out is because you could have the bot just scanning, looking for a target they can hit. Like they mentioned, there are other ways to figure out what a web server is running besides what the header actually mentions. And given how prevalent, reverse proxies are, you can't really trust that header anyhow. Especially if it only says Apache. It's not that much worse if it actually gives a version, but it makes it that much easier to kind of scan. It's just a defense in depth, like, maybe don't advertise that, but who cares ultimately? Like, it's not, if it's an issue, it's because you're running old software, not because you had the header.
Yeah. Number 6 was the classic scanning for vulnerabilities without doing any triaging work. Just bogging down security people with like useless reports with no information, just like, here's something I found, and nothing about like what it actually is.
Well, more like you're including a library with a vulnerability, but not actually looking if they use the vulnerable function or expose the vulnerable function.
Things like that, yeah. The top one was reporting that autocomplete should be set to off, because autocomplete is very dangerous, and it's not like we'd want people to be able to use their password managers. So
and most browsers ignore this anyhow. Yeah, like it's not even supported in Chrome, Firefox. I'm not sure about Safari, but I would assume it's kind of followed because it's been a few years at least since autocomplete has been unsupported. But yeah, even just in terms of its support in general, like it also kind of ruins it for like password managers and all of that. So yeah,
you're just like breaking your application basically for your user if the browser doesn't ignore it. So yeah,
one that I kind of has always annoyed me is the rate limiting one, or just missing a captcha. You can they use the example of an attacker could use this vulnerability to bomb the email inbox of a victim, depending on the level of capture brute force. It's like, especially talking about brute force on like a login, you're not brute forcing a password on login. You might dictionary attack, maybe, like that's somewhat feasible, but generally speaking, if you're going to brute force a login, it's going to be very loud.
Yeah, so quite a fun list with some fun quips in it. So if you're looking for a bit of a laugh, you can check out this post. But it is mostly just like lighthearted fun. There's not really anything super serious in there. But
honestly, it was a good post. Like it, especially if people are getting into bug bounty, they're probably going to come up with some of these issues and see them. As they mention here, like burp reports automatically on some of these. Of course, the idea there being somebody, a human in the loop, can actually look into whether or not it's worth reporting. But like, I think it's actually a really solid post, especially as an April Fool's thing. For some people, I think I guess I'd put it this way: some people really need to read this.
Yeah, it's one of those lists of what not to do. But yeah, I guess like for the people who need it, yeah, this could be a useful post. I'm sure some people will feel attacked, kind of like you did, but probably like more rightfully so. But yeah, I mean, it's also like lighthearted fun. If you like, you could probably guess what a lot of these are. It's a fun read. With that said, though, we'll move on to our exploits portion where we'll talk about some attacks. Our first attack is from F-Secure Labs. This is about multiple bugs they chained together to take over a WinVision account from the WinVision mobile app. WinVision is basically a TV service from a telecom company in Greece, from what I can gather. The issues had to do with authentication flow when it came to OpenID Connect, something we've talked about quite a bit lately on the show. They discovered a culmination of 4 issues. So they kind of go through them in bullet point style. First one they mention is the usage of deep links instead of app links and opening a web view for getting credentials. Basically, when they specify the intent in the manifest for the application, they don't specify the auto-verify filter on it. So like a link can be opened by any application instead of only the designated app, which gets associated with it and verified at time of install. So because it's a deep link and it's not exclusive, another app can effectively trick a user into setting itself as the preferred handler for a link and get a somewhat permanent access if they select always. Z, I think you've talked about this before, right? I think it's been a while, but
no, we've talked about the exposed intents where they'll have an intent exposed that like another application can call, which will open up sensitive functionality. So there's an auth bypass doing that. This is a little bit different from that. There's an auth bypass in like OpenCloud or something like that. I don't recall what episode that was in, where they were able to invoke the intent for like the privileged page and just access the privileged page that way.
Right. Okay, that rings a bell.
Yeah, this is a little bit different because it needs... You couldn't just directly invoke it. It's still getting... when it's opening the intent, it's passing back in the authorization code to do the rest of the OAuth flow. So there's still more required. You don't get to skip the authentication in this case. It's able to be invoked or passed around through an untrusted source in this case.
Yeah, I thought it was a slightly different issue, but I couldn't remember exactly what it was. But when
I've talked about
it rung a bell.
The exposed intents a few times before.
Yeah. The second problem they go through is the OAuth flow not using proof key for code exchange. We've kind of talked about why that's an issue in a previous episode, but essentially the problem is if an attacker can compromise the authorization code, they can exchange that for an OAuth token with no additional cryptographic verification needed. The third issue was device IDs were not generated in a secure way. When generating device IDs, they don't use any like cryptographically secure random source. They just take a property of like the media DRM service and a few other constants and throw it in a routine to calculate a device ID.
Yeah, and I can kind of understand this as a design choice. Because you kind of end up in this scenario where what if you want somebody to register their device and let's say they reinstall the application? Do they need to go through the entire process again or just be able to reuse like the same old device? So by using this where it's a static code that's created, it's unique to the device in theory, but it's not unique to every application. So any other application can also install it. I think that's kind of where they failed on this. So say if they were to hash this value with a seed that's app unique, although that, reverse engineering could uncover it. Like, I think usability kind of comes into this one.
Yeah, that's fair. Kind of that security versus convenience trade-off. The last issue was the leakage of the master PIN code for changing settings. It would be sent over HTTP to be authenticated with the server, but as shown with the ability to hijack the authentication flow, this could get stolen just like the authorization code could get stolen. So there's a good image near the end that demonstrates the attack path taking advantage of all these issues.
Yeah, and I'll actually just jump back a little bit to the start of this. That first vulnerability when it comes to using a deep link, zip, and app link is really kind of the key to everything here. Because using that, they're able to have another application, some malicious application, can receive the authorization code for the OAuth flow. And then they're able to go ahead, authenticate with the backend GraphQL API and start making all of the GraphQL requests, which is then where they can do things like see their settings and get the master PIN out of that, or update the devices that are registered to add in, the attacker's device to be registered. And that's where knowing the device ID. So it all kind of comes back to being able to intercept that first authorization, and then they can do all of these things.
Yeah, so I kind of pulled it up on screen for those who can watch. They have a nice little diagram that shows how the different issues play into an attack and the two types of attacks they can lead to. So they have like combining the login, the hijack, the OAuth flow, and the reproduction of the device ID to do an account takeover, or you can combine that as well with the exfiltration of the PIN code to lock the user out of their devices, like Z was saying. So yeah, that's a pretty good diagram that kind of sums it up. They do also have a bonus issue where they managed to bypass the update restrictions in order to continue their analysis of the bugs they discovered. The application will try to prevent you from using it if an update was released and you're on an outdated version. But that update check was basically just a dialogue, so you could just like patch it out at runtime using something like Frida or repackage the app without the check in it, for example. So yeah, that was kind of a bonus issue, but that's also, it's not really an issue like the other ones are. It's kind of something where that's kind of hard to prevent, being able to bypass those updates or somebody live patching your app. So but they just kind of toss that in there. But yeah, overall it's a cool set of attacks. It does rely on a pretty like specific scenario. Like this isn't going to be able to hit on a mass scale or anything, but yeah, I think it's still a cool series of issues.
Yeah, actually, speaking about it hitting, they have an example of like their fake app. Let me see if I can find that image. Yeah. So their image here of the WinVision app, and it goes through and it asks you after you submit your credentials, open with, and then WinVision, or WinVision underneath it, the little subtext complete login. That's a fair way to, social engineer somebody into selecting the wrong application. It's like, yeah, I'm in the middle of logging in. Let's use the one to complete my login. Like, it makes sense. I just wanted to call that out as, like, I could understand somebody falling for that. Especially when we're talking about people that are, well, not everybody using it, but you could imagine some of the users not necessarily being too tech literate. This isn't. It's an application with kind of a mass appeal, at least within Greece, for getting digital television service.
Yeah, it's not a niche app that's specific to technical people, basically.
Yeah.
So, yeah. Up next, we have a post from TrustWave, which details an authentication bypass in a content management system called Umbraco. I think it's Umbraco. I don't know if that's the right way of saying it.
Yeah, I don't know.
It's just one of those words. But yeah, in versions 8.9.0 and lower, they had multiple endpoints in the logging area that didn't check user access, which could lead to lower privileged users being able to get access to information that's usually kept behind a privilege wall. There were several endpoints, including endpoints for getting like saved searches, getting logs, the log level, number of errors, and languages. Basically, though, I think what's mostly important here is that the log data gets leaked. So, like, if there's any tokens or anything sensitive that gets put into the log, which has happened before, for sure, those could potentially get leaked. That said, I don't think they point out an instance where that happens, but it is like a possibility that's worth being aware of.
Yeah, it depends on your configuration as to whether or not that will be logged. That said, if it's logging anything really sensitive, like that is an issue on its own. Like, they use the example of like logging bad credentials when somebody tries to log in, and of course, if it's just a typo, it's just like one character off from the right credentials. So you can leak somebody's credentials that way. If it's logging that, like that is an issue on its own. It shouldn't be logging that sort of sensitive information in the first place, especially not credentials. Although, you have the case where a developer, trying to debug some issue, just like logs the entire post body and just happens that the issue occurs during the login or something like that. And it happens that they start logging passwords. Like that can happen. But it's its own issue for that. Spectre, I remember you weren't too happy about them calling this a local privilege escalation.
Yeah, so I will quickly say the title because it is relevant here. They have the title as Elevate Yourself to Admin in Umbraco CMS. I have a problem with the title for sure. Because basically what this is, it's a pretty trivial issue. It's being able to get access to logs because endpoints aren't checking auth properly, which we've seen quite often on this show. Calling that a privilege escalation, I personally have an issue with. I mean, I know it's kind of used that way. Z, you've kind of told me that it's been used that way in other cases. Yeah, I just personally don't really like it. Because it makes it sound like it's blowing it out of proportion, basically.
It is. Like, the title, I feel like, is blowing itself out of proportion because it's only elevating to admin in a very particular sense and case. That said, calling it like a privilege escalation, because the issue here is that those endpoints don't actually do any of the authentication checks. The issue isn't the fact that you're able to read the logs, it's the lack of authentication. So like the issue has to do with the authentication, not the leaking of information. So because of that, like it's a privilege escalation. You are accessing an administrative feature. So like I could understand where they're coming from. I do think the title's overplaying it. Like I agree with you there. Saying elevate yourself to admin is a bit misleading because you don't have full administrative privileges. You have admin access to a couple of the endpoints that don't check authentication.
Yeah, I think it's just internally in my head when I see privilege escalation, I think somebody being able to do exert influence over the system with that level of or with that gained access, right? With this, you're not able to influence the system at all. You're pulling you're reading data that is behind that should be privileged off, but it's not like you're then able to use that to get admin access to modify other accounts or something. That's where I would typically associate like a privilege escalation in my head. That might just be like me personally though. Like if so, fair enough. But yeah, I mean, they definitely overplayed the issue in this case.
Yeah, I think it's a bit of a matter of perspective. Like you said, you focus on the fact that it's only reading this information, but this same bug very easily could have been any other endpoint that just didn't have I think it was just an annotation that they mentioned. Wasn't or yeah, I think that's what it was. Just that didn't have the annotation actually saying admin authorize. So like it could have been any other action too. It just happens that the vulnerability is very weak in terms of how it's exposed, but like the fundamental issue still comes back to just being a user accessing something that's only intended for admins, even though that intended for admin feature isn't very strong.
Yeah, so like the main point that I had, and Z kind of turned me away from it. So like Z and I talked about this a little bit before we did the show. But the point I was kind of thinking of was, if you have, let's say we translate this over to binary. If you have like an information disclosure in like kernel, right? Let's say you have a kernel info leak and you're able to leak sensitive pointers. You're not supposed to be able to have access to those pointers as a user land process. So is that technically a privilege escalation that you're able to read sensitive data from the kernel? And that's kind of where I was making comparison to this, is like, okay, you're able to get an endpoint that can read logs that you're not supposed to be able to have, but that in and of itself isn't giving you any control of the system. So is it still a priv-esc? Z, what was your rebuttal to that again? I think you were just kind of saying like it's...
My take comes back to what I've been saying here. Like in that case, like if you have an info leak that gives you information, nobody, like that's not a feature that you're accessing inappropriately. That's just a bug or a vulnerability that gives the information. Whereas in this case, it's a feature, it's intended to be there, and it's intended to be behind an administrative lock, and it's not.
Yeah, fair enough. So yeah, that's just kind of the comparison I had in my head that I thought I'd bring up, but yeah, it is kind of interesting, and I just wish like terminology was more clear sometimes. Like I think calling this an auth bypass would totally be fair, and I would be more okay with that, I think. But
although
yeah,
an auth bypass isn't a stride type, we're trying to be all professional.
we've got to be pen testing firm appropriate. Yeah.
Yeah, no, terminology kind of sucks. I mean, there's a lot of vagueness. There's a lot of options for how you can describe something.
For sure. And that is just kind of something that comes with the turf of like security. But like what makes it suck so much is it makes it tough for somebody that's like trying to break in and learn things. Having all these different terminologies that overlap and are somewhat adjacent. Like it's just, I wish it could be cleaned up, but it's not going to be. But at least, you know, it does lead to some interesting discussions like this one, I guess. But yeah, issue itself is not too interesting. It's just straight up just no authentication on those endpoints. So we'll move on to our next topic, which is a little bit more interesting, I think. These are multiple types of attacks based on a vulnerability in the netmask npm package, which is used to validate IP addresses against like private and public ranges and such. This package is now used as a dependency of private IP. If that package sounds familiar, it's because we talked about it and how holy it was back in episode 55 of the podcast. Now, this package is particularly interesting to look at for things like SSRF bypass, because like if there's any weakness in how the filters are applied for validating if an IP is private or not, that can be abused against anything that utilizes that package, which according to this blog post is over like 278,000 projects. So yeah, I mean, these can be pretty impactful issues that can affect like multiple things, not just one specific product. And they start off by mentioning another researcher that managed to discover and report an SSRF in private IP. And it was based on the fact that the first octet in the IP address wasn't getting evaluated to its proper decimal value, which is the format typically used in IP addresses. So if you pass like 0127.0.0.1, for example, it would just ignore that leading zero and think you still meant localhost, when in reality, when that was getting used, it would get evaluated to 87.0.0.1. So because of that desync, you could fool private IP into thinking that a public address is private or vice versa. And after digging into it, they found that issue wasn't specific to private IP, but it was rather an issue in the netmask package, which was a dependency of private IP. So they go through some of the potential attacks you can pull off of using this bug, and they mentioned like there's many possibilities that are opened up depending on the target. They just mention a few of them that they came up with in the blog post. But like some of the ways they mention is like delivering malware, for example, by using the octet to route to a server that the attacker controls. They also mention the ability of like spoofing Cloudflare IPs or IPs of apps used in the cloud by things like Azure services. But there's a lot of like different vectors you could take here. So this was a pretty important bug, and it was fixed quickly. Unfortunately, the fix process didn't seem to go particularly smoothly, and this is kind of where our title plays into effect. They tried patching the code for parsing the IP, which is in CoffeeScript, by the way, and they tried to make it so that if the first byte is 0, they'd parse it as an octal instead of an integer. And while this did technically work, it introduced another bug because it now made it so that hexadecimal would get parsed as octal too, because hexadecimal uses the 0x prefix. So they did another attempt to try to prevent hexadecimal, so that issue wasn't a problem. Though that wasn't a good solution because it had supported hexadecimal before, so it would have been a breaking change. So then finally, in another pass, they checked the second byte for an X character so that they could parse it as hex. So they checked for the 0 prefix, the 0x prefix, and just regular decimal. Actually, no, wait. Sorry, that was still broken too.
Yeah, that was.
Because Node.js's parse int function would strip white spaces, including the leading white space. So finally, after that, is when the bug got fixed. It took like 4 iterations to get there, but they did get there. While the fix process was a bit of a mess, though, in terms of timeline, the issue was fixed pretty quickly. It was reported on March 17th, and then it was fixed sometime between then and March 28th. So it was fixed within a week, since that was when the vulnerability was published. So,
but yeah, a fairly
kind of a funny
quick
issue.
fix for sure. Well, a lot of problems, but at the same time, I mean, because they were getting out so quickly, I don't see it as much of an issue. Although I do think like the decision to strip leading zeros, like that doesn't feel like an innately insecure option. It's just being aware of the fact that so many things will process a leading 0 as octal rather than just as, 001. That's still 1. So, I don't know. I feel like the bug is a little bit interesting for that case because it's not something that's, like I said before, inherently insecure. It's just because of that desync.
Yeah, it's basically a desync attack. It's like an HTTP desync, but with IP addresses. Yeah. So yeah, fun issue. But yeah, also a pretty impactful issue. So it's good that it got fixed fast. All right, so we have some HackerOne reports today. The first of which is about a HackerOne application, which is HackerOne for Jira. Which facilitates integration between HackerOne and Atlassian, which is used for like collaboration and project management and such. So like one of the things that allows you to do is synchronize issues with reports in the HackerOne bounty program, for example. The issue is in the getting started page for completing the integration step. Usually only admin Jira accounts are supposed to be able to do any configuration. The problem is the link they provide, which contains a JWT token, that token doesn't get properly validated, and non-admin users can link their HackerOne account with a Jira instance they don't actually have ownership of, which can lead to a few different things. For example, it could lead to like leakage of private project names. It could allow them to create issues inside of those projects. You can it's effectively a DOS because by linking the instance to your account, the original owner can't link it to their account. So
does it mention that specifically? That the original owner can't? I'd imagine you could have more than one account.
I think linked. They do mention the possibility of DOS.
No, okay. If they do, fine. I just don't recall reading that. I will also mention that part of the issue is that the page, this getting started with HackerOne on Jira. That page itself, that's where the JWT is actually echoed. And that page can be accessed by an unprivileged user, so they can get the token from there. And then it's just assumed when it comes out on the other end that, they're unprivileged, but they had the right token. But if that token were never exposed, the rest of it doesn't matter.
Yeah. So this does have a little bit of a race aspect to it in the way that I believe an attacker would have to get to this page that contains the integration link with the token and use it before the legitimate user does. So there is kind of that, consideration.
Tough to hit that. I mean, it is at a static URL-ish. I mean, it's obviously dependent on the domain of the Jira instance, but beyond that, it's a static URL. So, you could be refreshing that, if you know what's going to happen. This really feels like the type of thing that's going to end up being more of an insider attack, not a privileged insider, but still an insider nonetheless. Who's going to know when they're going to try and install HackerOne, have some of that knowledge, or at least, I guess, scripting it up, maybe. But then you need the public Jira, and public Jira for HackerOne probably isn't going to be the best situation to be in. So, yeah, I mean, it's definitely limited. It's an interesting attack nonetheless. I think that's still kind of a cool attack, but definitely limited in terms of who could actually pull this off and how easily it could be pulled off.
It's mostly theoretical. So HackerOne fixed the issue by restricting it, so not only can users with basic privileges not integrate, not even admins can integrate now. They made it so only system administrators can. So that even kind of eliminates that insider attack possibility. So very interesting report. Even HackerOne staff noted that they hadn't really considered this type of issue before. And they were very grateful for the back and forth with the researcher trying to work things out. So much so that they paid a $2,500 bounty and also a $500 bonus for the report quality and collaboration. So, yeah, I mean, the researcher got quite a bit here. And it is a cool attack, even though it is mostly, like I said, kind of theoretical. I don't really see a situation where this is going to be abused. Because even if you go with the insider angle, this is going to be quite noisy. So it's not really a great attack to pull off if you're trying to do something, but it's a possibility nonetheless.
Yeah, I mean, I feel like, especially in this case, where only one, where you end up with a denial of service situation, definitely makes it a lot louder, a lot harder to pull off, and get follow-up information out of it. That said, the same vulnerability could probably exist or be done in other ways that might allow for linking more than one account. It might not be quite so loud.
Yeah, for sure.
Just not with this particular application.
Yeah. So our next HackerOne report is in Kaspersky's internet security product. The issue is the ability to inject DLLs into the executable, which is not normally that interesting, but obviously when you're talking about something like an antivirus, that is in scope. They do try to prevent injection, but they allow certain file names through. Probably this is mostly abuse of an allow list or something like that. One example they use is the tip tsf.dll driver, which is an accessible DLL for the touch keyboard and handwriting panel text services framework. If you name your DLL that and inject it, the antivirus will just let it through. It won't do any verification on that driver to make sure that it's actually the legitimate driver. It doesn't check its signature. It doesn't check that it's coming from the WoW64 directory or whatever, a controlled Windows directory. So using that, they can then hook into the process and disable antivirus. Turnaround time was not super awesome here on this report. Issue was reported May of last year, and it was fixed. The fix was shipped January 10th, from what I could see. So it seemed they had some trouble implementing the fix. They initially tried one, and the researcher said, yeah, this isn't good enough. I can still inject. They tried to test the path to ensure that it would allow the legitimate name of the DLL as long as it resided in the System32 or SysWow64 path. But the check was bugged. after doing some reversing, they pointed out the bug in their implementation. It seems they don't properly set the size of the string for the comparison, which is kind of strange that
I mean,
they made that bug.
Yeah, this is literally a CTF bug.
Yeah, and considering it's a fix for an issue that you have, like, you would think they'd be a bit more thorough about it, but apparently not. So, +1 to the botched fixes counter. But
And just
yeah, eventually.
To be clear, basically having a 0 size when you compare something and you're comparing 0 characters of it, of course it matches 0 characters of another thing.
I mean, I'm pretty sure we literally had this problem as a spot the bug challenge on our live streams.
Yeah, it was.
So, yeah, I mean, it's a funny issue, and it's like you said, it's mostly something you see in CTF, so you don't really expect to see it in an antivirus product. That said, I will say I'm surprised that Kaspersky has a program where they pay out, and especially like $2,000. Like that's a fairly significant amount.
Yeah, it's
so
a fair
I will
amount.
give them credit for having like a paid bounty program. So
another thing that I'll call out though, and this is just more the fact that the same exploit script or test script worked after they patched it. Like the fact that they didn't even try the payload that the researcher provided. After they patched it, they didn't even try to see if it no longer worked. They just assumed that's fixed and, away you go. Like, they didn't even test it with the provided payload, which is just... It doesn't give me high hopes for Kaspersky's products.
Yeah, it kind of implies that test-driven development is not really...
Not even that. Like, it's... You have this test case where it's like, I'm fixing this bug right now. And at least to test it and see that doesn't work. Oh, no. I mean, I guess it's possible, they didn't pass it over to the developer. Could be something like that, too. I guess, in fairness.
Could be some communication breakdown, yeah.
Yeah, the fact that they're not even doing the signature checks is a big red flag.
Yeah, for an antivirus to not be doing signature checks on drivers, that's like...
Well, on DLLs,
actually, like,
I guess,
really
in this
weird.
case. Was this a driver DLL? Yeah, it was. Sorry.
Yeah, like, this is kind of damning of Kaspersky, but hey, I will kind of bring back what I was saying with, at least they have a paid bounty program, so they do have, like, usually a paid bounty program is kind of a good indicator of, like, a healthy security stance, that they're willing to do that. But it's weird they have these other red flags. I don't know. Maybe they just need some time to work on that. I don't know, but it's definitely a strange report with some of the things that came out of it.
Yeah.
So our last HackerOne issue is a Rocket.Chat Sword XSS. Z, I know you found this interesting, so I'll let you take this one away.
Yeah, I thought this one was kind of interesting. So with Rocket.Chat, they end up running kind of two, I'm going to say functions. I'm not sure exactly, like 2 libraries, whatever. They had AutoLinker and Markdown. AutoLinker kind of does what you'd expect. You give it some text, it finds links in it, and it rewrites them as like clickable links in HTML. Markdown, most of us are probably familiar with it, just kind of a way of writing text so that it has some sort of format, and then it can turn it into HTML for kind of a nicer display, including a link format. So I thought this one was interesting, just because you are able to get cross-site scripting, mostly because of the fact that both of them run and both of them just kind of expect to be given plain text. They don't expect HTML to already be in there. So what ends up happening is that you can, if you're watching the stream, you can kind of see this payload here. It starts with https://a?p=, then those 2 square brackets and empty content. That's the start of a link, and then the normal brackets, rounded brackets, with a link inside there. That's in Markdown. That's kind of how you do a link. The square brackets contain your text, and then the actual href value is in the brackets, or in the rounded brackets. So AutoLinker comes through and goes, hey, here's HTTPS, whatever. That must be a link. Let's take this entire word and let's toss it in as like the href and rewrite it as a link. And then Markdown goes in, processes the same thing, sees what looks like a Markdown link, sees that there, sees it, and rewrites it out of the HTML. It goes and rewrites it into its own link, kind of injecting that href or ahref a second time. And it's already inside of an href, so when it does it the second time, it ends up breaking out of it. And then if you see on screen, they show the example output there of the HTTPS : equals. That threw me off for a little bit. I didn't know what happened there. I'm assuming that's actually the browser fixing up the markup a little bit and not what it actually output. I would assume it actually output the HTTPS : / as you would expect there. And it's just the browser saying, I have no idea what to do with this. Let's make it look like this. Just turning it into an attribute with an empty value. And then the actual XSS itself, I thought was kind of an interesting technique. What they did was they added a style with animation duration, animation name. And then to actually get the code execution, they used onAnimation iteration as the actual trigger for it, which I thought was interesting. I mean, I've seen things like on air. I haven't actually seen animation used like this to get code execution. So I thought that was a cool aspect to this. But also just the fact that, AutoLinker and Markdown together make sure they know what they're processing. In this case, Markdown was expecting text, not HTML, so it didn't even think to secure that first href because it just sees it as text.
Yeah, so as is the theme of this show, again, the vendor attempted to fix this, and the fix didn't fully work on the first go around. They attempted to add URL validation by relying on the URL class constructor to throw an exception if the URL wasn't valid. But that was bypassed fairly easily by the researcher. They just had to get a bit creative with the payload. I don't know why they didn't just either separate the Markdown and the autolinker or just do URL encoding. The researcher, I think, suggested that, and it seemed like they were just like, oh, we have a fix in progress already, and we're just going to do it our way.
Yeah, I really think Markdown, if it just did the URL encoding, which a lot of them will do, I'm not sure how many implementations you're actually going to have with this sort of vulnerability. Because a lot of them will do that encoding. The fact that this one doesn't is actually a red flag that there might be some further possible issues. Or at least that doesn't in this case. Does do some encoding, I can see. I don't know. I mean, I think that's worth digging into a little bit more, actually.
Yeah, it's a potential code smell, yeah. So the final suggested fix that I believe got implemented was just to make sure that you couldn't have the link rendered if it had other Markdown tokens in the URL. Just doing that separation. Yeah, I don't know what it is with this episode, though, and broken fixes. It's kind of it's not really something that was an issue on our past episodes with the show. We just have a bulk of them. Did you cherry pick for these, Z? I don't know.
Nope.
No? Okay. Weird. All right. Up next is a really cool blog post about macOS and opening text files. It's taking advantage of a file format that's typically seen as benign, right? The article even points out that often text files are ignored by antivirus and whatnot because text files are just text files. They don't have any special data parsing or anything like that. They're pretty straightforward formats. The most straightforward format, actually. But this is abusing a really weird thing in TextEdit on macOS, where it would parse a .text file as HTML if it began with a doctype HTML tag, even if the file extension wouldn't indicate that it's an HTML file. So that opens up some attack surface where you would never expect there to be any. And after some fuzzing and trial and error, they found two interesting vectors that could be abused here. One of which was the ability to import local style sheets. Now, when you do that, the URLs that you provide are limited to the file scheme, which means you shouldn't be able to send remote requests out to an attacker-controlled server or something. But you could use it to load local files and do a DOS, for example. Make it read from dev.rand or some other device with an infinite stream of data, which is neat, but not too impactful. DOSs are kind of
as a DOS, it feels a little bit weird because it should only really be DOSing the one program. You're not killing the entire system even though it's doing a constant write, like that shouldn't kill your whole system. It'll kill your text editor at most. So like as a DOS, it's almost like a self-DOS of just the one program of itself that doesn't run anything else. Like it's not like killing a server with a request.
Yeah. The more interesting route they discovered, though, was the discovery of the auto mount feature through AutoFS, which is typically used for making mounting requests for a drive. And it also supports being able to make remote requests to an external drive, which you could abuse to make it send remote requests to an attacker-controlled server. Now, again, you're going to be kind of limited to what you can do here, but just using this on its own, you could use it as like an IP grabber, for example, which is what they demonstrate in the posts. But you could do more interesting things with it too if you chain it with another vector, which I'm going to talk about now, which was the ability to embed local files using iframe docs. So with that, you can embed something like the etc password file in the document or any other file. And while that might not seem too useful at first because you can't run JavaScript or something to exfiltrate the contents, when you chain it with the first vector, you're able to abuse like a dangling parameter to leak it to the remote site.
Yeah, and just to kind of clarify for people listening who can't see this, like, because this is a very non-standard thing to be seeing, but like using the iframe doc, we've got an image here that shows the example where like they just include the iframe doc source equals and goes to etc password. And it literally just takes the content that's in etc password and pastes it in. So it's like another file inclusion type situation. That is very much a non-standard way to do an iframe. Oh, but the fact that that's there, as Spectre was just about to get into, being able to exfiltrate some information by pasting the content or using an iframe doc of a file that you want to exfiltrate, and you can put it into the URL of the style source. Now, this post doesn't actually include a proof of concept for that, but my understanding from what he's saying there is basically exactly that he's just using this iframe doc as part of that style URL, that remote. So you just like create a parameter, question mark exfil equals, then you put your iframe doc there, and it'll just replace the iframe doc with the content of the file, and anything that goes along with it will be sent off when it tries to retrieve the style. I do find it an odd choice that they didn't want to include a proof of concept for this, because one, it's already patched, and should have been patched, so...
Yeah, not recently either. This has been patched since 2020. Because the CVE is a 2019 CVE. So. Yeah,
and patched sometime by Q1 2020. I feel like the decision not to include it is a little bit... I don't know. I mean, if you're writing up a vulnerability, just write it up. Like, give the information there. Like, withholding this, especially withholding this when it's so trivial, it feels a little bit almost arrogant on their part. Like, I kind of get maybe they're coming at from the perspective of, let's not support the script kiddies by giving them something, but this isn't that dangerous, I guess. Like, I mean, it's definitely an issue. I would also disagree. He says, given how simple it is to exploit, I'd give it a high CVSS.
I don't know about that.
Yeah, this is squarely medium, in my opinion, and I actually did try and figure out a score for it. And I ended up scoring it, I think, like 6.5, which would... Yeah, 6.5, putting it pretty medium. I could bump it up into like 7 point something, which could be called high, if you included the denial of service.
But it's not really a useful DOS.
Yeah, so. Its availability is the CVSS thing, so if you set that to low, it'll jump up a little bit. But as I was saying there, like, your DOS is only against that file that you're opening. Like, you're not DOSing anything but your exploit. Like, your exploit crashes, but it's not killing anything that you need to have available. So, like, I could understand somebody arguing to give that a low value. I wouldn't agree with that, but I could understand the argument there. So, yeah, just because something's easy to exploit doesn't mean it gets a high CVSS.
And yeah, regarding the POC, like you literally POC, you wrote up a little POC in like what, a few minutes of this. Like it's not
Yeah,
a super
well,
complex
from
thing.
what I could understand or what I got from this, yes, but I don't have a copy of this to actually try and see if that would have worked.
You can't verify it.
Yeah, I didn't bother verifying it, but it seems like it since he talks about dropping the iframe doc in a parameter, and the last thing we talked about was that style import file equals like doing that. You combine the two issues in basically the only way you could. I mean, I'm sure other people have also POC'd it already.
Oh, for sure. But yeah, like while we, like, I'm kind of in agreement with you. I don't think this is a high just because it's easy, but I will say this is still a very cool attack.
Oh yeah, cool attack. I don't want to downplay there or anything. Cool attack and a really good write-up, except for that ending. Ending was a little bit anticlimactic.
Yeah. So yeah, you're basically able to remotely leak any file the user has access to by getting them to open that text file. And it's fun to see assumptions that are commonly made get challenged. I've definitely fallen into that category of thinking, oh, a .text file, all right, that's safe. Like, I don't really... if I receive a file from an untrusted source and it's a text file, I'm a lot more likely to at least consider looking at it than I would be, like, I don't know, a zip file or something, for example.
And you're probably not using something that decides that anything can be HTML and actually does like this file inclusion.
That is just really stupid on this program. I don't know what, like, I don't know why TextEdit would do this. But yeah, I think many others fall into that category too, because it's typically assumed to be a safe file type. But with these weird kinds of issues, those assumptions can sometimes get broken. The issue was fixed. They don't mention how specifically. I would think that they just made it so that TextEdit wouldn't parse HTML anymore on text files, because that's just really messed up to me. And if they didn't fix it that way, then there's other possible attacks that could be opened up by this. So yeah, it's possible they just prevented the ability to abuse AutoFS to send the remote requests to, although I don't think they could easily do that because that's kind of abusing an intended feature. So
yeah, I can't see it getting fixed there. But
it would
I'm
have
not
to be
sure
HTML
what.
parsing, I think.
Yeah, that's
seems
where
most
I
likely.
target fixing it.
Yeah. We also have a Project Zero post in this episode. This one from James Forshaw about Windows Server containers. As is usually the case with P0, this is a researchy type post. They talk about 4 vulnerabilities they discovered, but they also talk about the background info and the research that went into it.
Yeah, and I really like this post because of that background. So we've actually talked about a couple of the issues found because they had Project Zero bug reports, which we covered, rather than waiting for an actual report like this. That said, I found, like, I really enjoyed the writing for this, at least for the most part. Like, I felt like it flowed nicely. It's definitely a bit on the wordy side for what actually is covered. But at the same time, I appreciate getting to see kind of the story, I guess, behind how some of these were found. Like how we talked about the container user issue, where the container user and container admin, you expect user to not really be an administrative account, but it was effectively an admin account, and that's one of the issues, or one of the first ones covered in here. We talked about that, and getting to hear the story of how they came across that as basically just like somebody had suggested that would actually be a mitigation for another issue that he talks about. And it's like, well, we just make sure everything's running as container user and things should be good. And in fact, you're not. It's the same thing as container admin. Well, not exactly, but has SE impersonate privileges, therefore can get admin.
Yeah, so those 2 issues, so 2 of the 4 issues here we have covered before, like Z said. Those were back in episode 68 for anyone who wants, like, when we covered those vulnerabilities, just the raw reports. But yeah, like, mostly what's of value here is the background information. Now, it talks about how containerization works in Windows 10 and how silos work. The term silo is used a lot here. It might be a bit confusing if you're not familiar, because it's yet another term that Microsoft seems to have chosen as if it means something without actually defining what it is, at least not in public documentation. Basically, as far as I understand it, it's a feature to like redirect or overlay resources so that you can't access host resources directly. So things like the registry or like the file system or whatever, those are contained in a silo.
Yeah, it seems like it's a sort of container. Like most people, I think, are going to be more familiar with containers. Kind of like that. Almost feels a little bit like jail or CH rooting, even.
Yeah, that'd be, I think like a BSD jail is kind of like a good comparison. So apparently you can have two types of silos for Windows containers. You can have server silos for things like the object manager and registry, which require admin permission to set up, and application silos, which I think do kind of a similar thing, but they don't require admin permissions to set up. Unfortunately, I can't really talk about the differences too much because I don't know what they are and they don't really point out what they are.
Yeah, that's actually when I was saying, like, I mostly like the writing of this. I thought it was well written until I hit that point where you start talking about the application silo, and I realized, like, right there, it's just in the case of Desktop Bridge, it uses application silos rather than server silos, but they go through similar approaches. That's the first time we're introduced to application silos, is when it's actually being used and the difference matters.
Yeah, and unfortunately, like I said, there's no public documentation from Microsoft on this because the way that this container service works is you're supposed to interface with it using a library they provide. Or a binding that they provide, and like Docker and whatnot is going to be handling that internally. It's not something that people are supposed to be using on the masses, so Microsoft just doesn't have public documentation for it. So unfortunately, there is that like bit of confusion when we get to that issue. So yeah, that's not important for 3 out of the 4 issues, but for the last issue, just keep that in mind. There's also 2 different types of containers that are supported. There's Windows Server containers and Hyper-V isolated server containers. The difference between that is server containers are basically just a separate process running under the same host, whereas a Hyper-V isolated container also runs inside of a VM. So the Hyper-V containers are more secure because with server containers, you just need a kernel exploit in order to escape it. Whereas with Hyper-V, you also need a VM escape to escape those containers. Interestingly, apparently Microsoft doesn't consider server containers as a security boundary. Kind of falls into that category of I feel like it should be a security boundary, but they don't consider it one.
Yeah, it reminds me of like UAC, where
exactly
it's it's presented to people in a kind of security sense, but they don't actually care about it as a boundary. I mean, I can understand Microsoft in some sense, where again, similar to like CH roots, where if you're root, you can escape your CH root jail, and just deciding on like that's okay, like it's up. Microsoft is more than allowed to decide on that, but when things kind of get presented in this container and stuff, like you expect them to actually support the isolation, I guess. I agree.
Its intended purpose.
It feels like a security boundary they should consider, but it is pretty consistent with other things that they've done that they don't support as a security boundary.
Yeah. So James then goes into the research process and some of the thought process behind looking for the issues. For the setup, he used Docker, which uses an MS Go wrapper for interfacing with the Windows container code. First thing he did once he had a PowerShell inside of the container was to see what privileges were given by dumping the token. The first 2 issues that are walked through I won't cover in depth because, like I said, we covered them already on episode 68. But it basically came down to discovering that the container had a token which granted the impersonate privilege, as well as ignoring registry overlay, granting the user direct access to host registry keys that it had privileges to instead of using the overlay. He then dug deeper into the functions that were exposed for getting the silo state from the container and found 2 more issues which we haven't covered yet. These were more technical flaws compared to the higher level flaws like the first 2 that we covered. The third issue seems to be a forgotten functionality left in from the development process. It has to do with symbolic links, which, of course, I mean, we're talking about James Forshaw. So normally, if you try to put a symbolic link from the current user's Hive to direct to the local machine's Hive, it'll fail when trying to open a registry key, so they can't traverse from an untrusted Hive to a trusted Hive. The problem is, in the function they use for enforcing that, they check if the thread is currently in a server silo, and if it is, it'll just return true and bail out. While they have a check to check if the source Hive is trusted or not, that just doesn't even get used if you're in a server silo. So it's just kind of one of those cases where the control flow was a bit wonky. The final issue is going to be a little bit hard to cover because, like I said, they don't really talk about application silos. But it's a confusion when looking up a path in the object manager namespace. When they do that, they check if the process is inside of a silo. And if it is, it'll attempt to query the root directory object on that silo, retrieved with the ps_get_current_silo function, basically doing like that ch rooting like Z was mentioning. The problem is that function just returns the first silo it sees, which could be a server silo, but it could also be an application silo if the attacker sets it up properly. And as I understand it, application silos won't have a new object manager root directory created for it, whereas server silos will. So that confusion allows a siloed process to access the real object root manager, to be able to access like named kernel objects and whatnot. So I guess that is one of the differences that is pointed out in the blog post between application and server is, I guess application silos don't do that like ch rooting. I don't really know why, and like I said, that's just kind of like speculation of what I was getting out of the blog post, but it is a little bit hard to say for sure without documentation to work with, especially where I'm not a Windows person. But yeah, like these are kind of complex issues that, well, at least the third and fourth ones, where you kind of had to dig into the code and look at the control flow to see what the problem was. And yeah, I mean, this is just a cool post because it's in a fairly new feature. Like these Windows containers, I think, only became a thing starting in like 2019. So it's a very new feature to Windows. It's not publicly documented because you're supposed to just use the wrappers provided. So that already makes it an interesting attack surface, right? It requires RE, it's gray box, which makes the background information here extremely valuable. Though, like I said, like I do find it a little bit disappointing that there is some context missing for one of the issues regarding the silos, but I feel like they should have elaborated on that a little bit more. But
yeah, on the whole, though, like I felt like it was written fairly well and fairly or reasonably clear. It's just that one thing with the application silo that really kind of caught my attention as being a problem.
Yeah,
like on the whole, I really like this, and I was kind of wondering, like, have we seen any other posts from Forshaw on Project Zero that we've covered?
I can't think of any at the moment.
We've talked about Forshaw quite a few times. I mean, especially because of his symlink research.
Yeah.
I just can't think of us actually seeing some of his writing here, unless maybe...
I feel like we might have covered some bugs he's reported on like the Project Zero bug tracker, but I don't think we've covered blog posts.
Yeah, no, we've covered that because we've talked about the two that we've covered for sure that were from him. Yeah, no, I'm just saying that because I really appreciate his writing style. So, I mean, I hope we see more from him in terms of the blog posts.
And the diagrams and stuff are very like well done too, and help in understanding. And I will add a devil's advocate too, in the way that I believe he's approaching this like entirely from a reverse engineering aspect. So part of the reason they might not detail like what an application silo is by comparison is they just might not have dug into it very much, right? When you're doing reverse engineering, you kind of have to follow what paths you find interesting, and if you get caught up in trying to reverse the entire system, you kind of get caught in that trap of like you're almost doing it just for the sake of doing it instead of doing it for vuln research. So it's totally possible that they just don't have that elaboration because they hadn't really explored it too much. So yeah, I mean, I don't fully blame them for not documenting that. I kind of blame Microsoft, actually. It's kind of annoying how much they feel they don't need to document anything. Like they just invent these new terms and use them as if they mean something. Like they're like, you're not supposed to do anything with that code anyway. So we have internal documentation on that, but we're not going to say anything about it publicly. Like it's just, it's kind of annoying to me. I get the fact that, like, I kind of get where they're coming from, where they don't feel the need to put that out there publicly, but oh man, it just makes trying to follow some of the security research around it really annoying. It's like the most off-putting thing with Windows for me is how secretive Microsoft is with like its terminology and documentation.
Yeah, but it does seem like this is intended to at least somewhat be used, like by people. I mean, yeah, he's using kind of the lower level calls to it that aren't exactly documented. He just got them out of like the Go wrapper and stuff, but it does seem like at least application styles are something that's expected to be used, at least by like Docker. So in theory, anybody else too. Either way, the information's not there, and we can leave it at that.
Yeah, it's just kind of strange. But we also have a ZDI post in today's episode. It's a write-up from Trend Micro's research team for a bug discovered by a team from Alibaba Cloud, discovered in Apache Druid, which is an analytics database for storing and querying of like analytics data, telemetry, stuff like that. One of the things that Druid has the capability to do is execute JavaScript on the server side on various user requests, but it is disabled by default due to how powerful that capability can be when exposed to an attacker. So it's intended only for use cases where you can completely trust the data going in. Very high trust setup, basically, is the only situation where you would enable that JavaScript execution. But this vulnerability allows you to bypass that. It allows you to make it so even if it's disabled by default, an attacker can basically re-enable it because they can get control over the settings. The way the bug works is based on how it parses JSON data for user requests, and the fact that when a JavaScript dim filter class is constructed, it uses a hash map for the creator properties, and one of the properties in there is a configuration which specifies whether or not JavaScript is enabled. The problem is the creator property used for that configuration has an empty key, and the code doesn't account for the fact that a user could provide a request that intentionally leaves the name field blank in order to gain access to that empty key in the hash map. So that gives you the ability to re-enable the JavaScript and run JS on the server side.
Yeah, and I'll kind of toss in here, like, this has to do with how like Jackson DataBind works, which is the main library that they're using, and then this is just one of the classes that can be created or deserialized through that. It kind of makes sense how they're doing it, where they basically go through all of the arguments there. If it has a JSON property attachment on it or annotation on it, that'll include what key it actually gets. That creator property that Spectre was just mentioning, it'll get that out of the JSON property annotation. So they've got like dimension, okay, that's in JSON property dimension, and functions and in the JSON property function, and so on like that. So what they end up doing is kind of making what appears to be a sane choice that, okay, if it doesn't have a name, then it's not going to be filled in, like no name. It just doesn't it doesn't have a property mapping to it. There's no name, so they get it that way. And like Spectre said, just because of the fact that you could create a JSON file, or not file, you could create a JSON input that has just that blank key name. So when it goes to parse it, it's like, oh, so what's the creator value for this one? Oh, it's blank. Well, in theory, there shouldn't be a blank, but you can collide with it, and that's, you can kind of go ahead and provide this value for the JavaScript config. Which, I mean, that's just a really fun vulnerability to take advantage of. I could imagine other places having this sort of issue. Because, like I said, using kind of that blank or like that uninitialized value, people do that all the time. You just check, okay, is this value blank? Yes, no, whatever, and kind of act based on that. And the fact that in this case, you can actually create something with that blank name creates the problem. I really like it. I think it has a lot of potential. And I mean, obviously, this isn't the first time we've ever seen such a vulnerability, but I don't know, seeing it here, and I don't know, when I saw Jackson data bind, I was expecting this to go a slightly different route, but I was pleasantly surprised.
What different route? Like just
Jackson data bind is, at least for me, so I was aware of like deserialization issues, but I feel like it was the deserialization within Jackson data bind, because this is a widely used library in like Java applications, widely used, and for a while there was a deserialization vulnerability in the core library. So basically anybody using this had an RC. That's not the case anymore. And this was, I want to say it was in like 2014 or so. I feel like that really kicked off a lot of the deserialization vulnerabilities that have been found. We're following that. I think you could trace back deserialization further than Jackson data bind. It was just, at least in my mind, this was like the big one.
It was like the catalyst.
Yeah, like there definitely were some before it, but yeah, this one, at least in my mind, and I think for some others, like, yeah, it was, as you said, the catalyst. Kicking off more people really taking it seriously and looking at it, rather than being kind of a more niche vulnerability.
Yeah, so the issue itself, from a high level perspective, is fairly trivial. The write-up goes extremely in depth into the classes and control flow, which I will say, like, if you're not familiar with the code base, it is like really hard to follow. To me, like, it was just kind of like word salad. I mostly skipped it, honestly, because they have like a few, like 3 or 4 paragraphs where it's like mostly it's code tags where it's like function names, and I was like, I don't know what any of this is.
Okay, I'm going to say I feel like they went a little bit excessive when they included the description of HTTP.
Yeah.
When they include, like, here's what HTTP, and here's a post request and how that's formatted. Like, okay, it's fair background because it's relevant, but I think almost anybody reading ZDI posts is probably going to be familiar with it already, and if not, like, can easily find that elsewhere. I don't know. It feels excessive to, like, start that fundamental, and just a lot of it is a lot of excess information.
Yeah, it felt a bit bloated, but that doesn't detract from the issue. It is a cool bug, but I would recommend skipping like some of those paragraphs, especially the ones with like all the code tags and them referring to the classes and methods. That is like additional information that could be useful, maybe if you're familiar with that area, but it's not really necessary to understand the issue. So we'll close out the episode with the big news topic of the week, which was a new speculative execution attack variant that surfaced with a new feature that surfaced in Zen 3 called Predictive Store Forwarding, or PSF. Now, fair warning here, there are a few things that I will kind of hand wave here on the terminology, because frankly, this is a little bit out of our like area. We're not people that work at like the CPU and microcode level. We usually work at a level or two above where speculative execution lands, but I'll do my best in a way to cover it in a way that makes sense. So to understand predictive store forwarding, you need to know a little bit about what store to load forwarding is. Store to load forwarding is when the processor determines it can optimize a bit by forwarding a stored value directly to a load without having to access memory or the CPU cache or whatever. So the situation you could imagine for that is like if you had a register value that's moved into a memory address, then immediately after that, the next instruction, that same memory address is read into a register. With store to load forwarding, you can kind of skip the middleman and just get the value you would have written directly into the register and save some time. Now, this isn't always possible to do. For example, if you store less data than you read, then that obviously won't work. You need to read the memory address, and you need the addresses between the store and the load to be the same, and the size of the access to be the same. What predictive store forwarding tries to do is it'll try to learn over time what the relationships are between loads and stores, and it'll try to guess where the location of store to load forwarding occurs. It'll remember those and then try to predict them in advance, try to predict them in advance before confirming if the store and the load are actually at the same address. So as you can guess, an attacker can basically abuse this to get a store to load forward operation to occur when the store and the load are not at the same address by training up the CPU into thinking that the store to load forward is legit when it shouldn't be. And the way they do that is one of two ways. They either force a dependency to get dropped or changed during execution, or they force an aliasing internally with a store load pair that has a dependency and another pair that doesn't. And a dependency there, as far as I know, is basically just like a relationship between the store and the load. So, yeah, it's worth noting the impact of this attack is quite limited. For one thing, this type of speculative attack cannot cross the userland and kernel space boundary. Code execution in userland will not be able to at least directly influence predictions done in the kernel. And another thing is, this is going to be isolated to your process or thread. You're not able to attack other applications because the predictive store forwarding predictor is isolated on a per thread basis. You can't use it to influence like another SMT thread or whatever. So
yeah, and this is still also kind of all of the memory access. They're still subject to like those standard paging checks, which is, I think, one of the places where Intel kind of got killed was because it would speculate across that boundary. And across the privilege levels, whereas AMD from the start here hasn't speculated across that.
Yeah, they didn't cut corners like Intel did.
Yeah, and I mean, on that note, I do want to give some kudos to AMD. Like, this is coming out from AMD's own research. This isn't, as far as I can tell, like a third party having discovered this. This is AMD went out and looked at it in their own, was like, this is what we found, and didn't like, or maybe they did. Maybe it's been in hiding for like a year before they allowed it to be publicly disclosed, but I get the feeling that they just disclosed it in a reasonable time frame.
Well, Zen 3 just came out like 5 months ago or whatever, right? So it's Zen 3 is pretty new.
Yeah, so I just kind of want to give them the kudos on that for being proactive about it. It's a fairly stark difference between what we saw with Intel handling these issues.
I was just about to say, they weren't like a certain other company that tried to bury and go after the speculative execution research, huh? Yeah, I mean, AMD is just kind of showing up Intel in so many areas, and one of them is just being more open, like you're saying, with releasing this report. They definitely didn't have to do that. They could have kept that internal. And again, that kind of defense in depth of being saved, like, even though this is an issue and you are like, this could potentially be used on like a browser or something, maybe, where you have a degree of control over the code that gets ran, but there's still a privilege separation. This could have been a lot worse if AMD did what Intel did and cut corners and didn't have that that page level boundary. Like, it's just kind of showing where that secure by design is really like prevented this from being a lot worse than it could have been.
Yeah, I mean, I'm not sure I'd go and say that AMD is secure by design. I don't know enough to really make that comment. But well, at least in this case, they made some of the right decisions and didn't just do everything for performance.
Okay, that's fair to call out. I shouldn't say that. That's kind of a bold claim to make. I'll say more secure by design than Intel. Is that better?
Yeah, I suppose.
Okay. But yeah, like, it's a very cool attack and how it works. And I will say, like, out of the speculative execution attacks we've covered, I think this was the most straightforward one to me. It made a lot of sense, and it was very well explained. Like, it's weird because this document is very short. It's only 6 pages long, which for like speculative execution attacks, that's really short. Some of the papers we covered on some of our earliest episodes with Intel were tens of pages long. But even though this is short, it's like very well written.
Yeah,
I found it clear to understand. Yeah. But yeah, that's all we have to say on that.
I guess part of that, though, well, I was just going to say, I think it's clear, but part of that, I think we have a better understanding over what speculation even is. with the early ones, it was still kind of a new attack, a new concept.
That's true. That's good to point out. But yeah, we're gonna move into our shout out section of the show. So Pluralsight is free for the month of April. We just wanted to shout that out. I think we were talking about it a little bit in the Discord. Yeah, it's a pretty useful platform. For those who don't know what Pluralsight is, it's basically a learning platform. They have like courses on there that consist of videos, and they have a bunch of different stuff, not just on programming, but some others. Well, it's mostly programming focused, but
it is all like tech focused. I've used this like myself through work. We had it, or actually, I think I used my budget on. Either way, I had it being paid for through work, and I would use it. I'd get on engagement, some new tech stack. I'd use it to find a quick course to just get up to speed on that tech stack that I was going to be doing an assessment on. And that worked fairly well for me. The courses, generally, like, they're fine. There's maybe better courses out there, but, like, you're not really being misled. There's a little bit more effort and quality control being done with Pluralsight than something like Udemy or Skillshare. I don't know how much tech you really get on Skillshare, but versus those platforms, there's a little bit more effort put into them. But yeah, it's a good resource. I'd say check it out. For the security content, it's not amazing, but for just general tech, I think it's still pretty solid.
Yeah, it's a bit lacking on security. But like I said, it's not just programming or security. They've also got like machine learning and data analytics and all that kind of stuff in there. It's kind of like a Netflix for learning courses. So yeah, I mean, where it's free, definitely check it out. You're not losing anything by checking it out that way. So we just wanted people to be aware that that's out there. Z, you also added a shout out with Pwn to Own. I haven't looked at this too much.
Yeah,
well, it's so new. So
there's not much to say. They started, or well, by the time people hear it, they'd have just started streaming on Tuesday. Some of the attempts for this year's Pwn to Own in, I think it's the Vancouver one. Yeah, like the normal CanSec West. So they're targeting, looks like browsers. There's Microsoft Teams in here, Windows 10, local privilege, VirtualBox. I think VirtualBox is newly added. I think it used to be in Pwn to Own, was removed, and now it's back on, I think. I see Parallels Desktop here also. VMware stuff has, I think, been in a lot of these, but yeah, just doing what Pwn to Own usually does. They're streaming it, they're streaming the attempts, doing some interviews with some of the people also, it looks like, so can be some interesting things out of that. A lot of the stream time seems to be just downtime, at least when I look. It's like, an hour of streaming and maybe like 15-20 minutes of content. That might get a little better as the day goes on, but we'll kind of see how that goes. But figuratively, if you want to catch it live, now is kind of the time to do that.
I've found it fun in the past to just follow the results live, like just see the Twitter feed or whatever and see what the teams are doing. I will say this looks a lot more interesting than some of the previous Pwn to Owns we've covered. For those who have been listening for a while, you may have heard me on the last Pwn to Own we've covered where I was like, this is like really boring because it's so much IoT stuff. This one, though, like Z was saying, there's some very interesting targets here. We're seeing like Edge, some other browser stuff, VM stuff. Like these are the types of categories I love to see. So,
and you said Edge there, and I had to go and look. So yeah, Edge Chromium version. So
yeah, not
Edge. Yeah. I was thinking like, isn't Edge dead? But yeah, okay, the Chromium version.
Yeah, Microsoft's Chrome wrapper, basically. But yeah, that'll be interesting to follow. We might cover some of the. I don't know if we'll cover the results on the next podcast. We'll see. I guess depends on.
We usually do cover the results.
We do, yeah. But yeah, we'll get to that next week. That sums up all the topics we have for this week, though. Thanks to everyone who checked out the video. Once again, sorry for it not going live. I would usually say thanks to everyone who tuned in, but obviously we didn't have a live showing. So the videos are up on Twitch or on YouTube, always on Tuesdays. We're also on Anchor. We're on most of the platforms that are common for podcasts. Follow us on Twitter and join our Discord for notifications and to join our community. With that said, we'll be back again next week live on Monday at 3 p.m. Eastern, 12 p.m. Pacific, and we will see you all then.